positive, there's a negative charge. Current of 1 ampere. So the length of this 0.1 meter. So inside, and there's a cell. Inside a positive charge, the positive charge which is present will experience a force 10 Newton and 8 Newton. Constant non-electric force of 10 Newton. I think these words is non-electric force of 10 Newton. The words are there, constant electric force. What do you mean by the 10 Newton? Tell me that who is that 10 Newton? Actually, we have discussed, no? The battery does work to displace a charge from negative terminal to positive terminal. There's a terminal A, there's a terminal B. So negative terminal, so what the battery force does work. This is what that battery force. Then the resistive force. So this is called like a total, the resistive force. The battery force does work in displacing a charge from the negative terminal to positive terminal. Different. So for that, and what is the force it will exert on that unit charge? Is telling that's a unit charge, unit positive charge. So you can write this charge Q. Later on we'll write Q equal to 1 coulomb. It's just asking you to go into the cell and analyze here. And what is this FR? Resistance offered by the material to the flow of charge. This like electric force only we should call this altogether. What is this battery force? Work done by the battery force to displace a charge Q from negative terminal to positive terminal. And the cell, what when the material of cell will offer resistance to the flow of charge. So that will become that there's nothing but work done to overcome the internal resistance. No, it is. So with that is asking find the EMF of cell and the difference across the cell. Is asking EMF and is also asking the terminal voltage. Both the things is asking you to find out. So what all you have to find out? EMF of cell and this difference of voltage means terminal voltage. Now really you have to work out. So some work done. What we discussed, no? Any equation. So you do one thing, just replace this with an equivalent circuit. If you're getting confusion, at least you do this much. There's internal resistance R, there's a terminal A, terminal B, this is EMF. So terminal A, this is terminal A, this terminal B, and this is the current which is flowing. Do we have information of current? It is a 1 ampere. What all we have to find out? The applied EMF and the terminal voltage. It's a really good problem for students to analyze here. And it's telling the battery force is non-electric force, as it should be, no? Now, what is that internal resistance? Internal resistance, what it is? Yesterday, I think I gave assignment in that internal resistance of a cell depends on, you look at the options, it depends on the material of the cell, the plates, these are the plates, no? In fact, the plates will be thick. The resistance of plates also will come into picture. Because the plates, they must have resistance. Even the resistance of plate also will come into picture. So these are the plates. This is a plate. So this is called plates here. Positive plate, negative plate. It depends on the material here. The interaction depends on material and the plates. This one. So all that it matters here. The interaction, not only material, even these plates also will contribute. Okay, directly you go for work done. For first, let's do one thing. What is a VA? You can write it. So current enters. This is a positive. Stick on to the basics. What you have. I'll write KVL. VA minus C plus IR minus VB equals 0. VAB equal to E minus I into R. What is that I into R? IR is what? Again a drop. How to manage things here, no? So we have how to bring that work done by battery force. What is work done by battery force? That should be equal to applied EMF, no? So here shall we multiply Q for both as it is a unit charge. I'm taking help of the basics here. That charge into potential difference is nothing but work done, nothing but energy, and force into displacement should be the work done, and it's also equal to energy from dimensions. So in place of QE, I'll write it as FB into L. In place of QIR, what should be written? 8 Newton into this. So this will be FR into L. So what is FB? FB into L, this will be 10 into 0.1. What is FR? 8 into 0.1. So how much I'll end up? 2 volt.
0.2.
So 10, this will be 1 minus 0.8, no? 0.2, I'll get it. So this is a joule, no? Per unit charge, will become 0.2 volt. Will I agree this? This will be VAB. Okay, I got the terminal voltage 0.2 volt. What about the applied EMF?
1 volt.
1 volt it should be from here. The applied EMF QE equal to FB into L. This everything should be 10 into 0.1 by charge is 1, no? Q equal to 1 coulomb. Unit charge we assumed 1 volt. So this is the applied EMF. Can we calculate internal resistance? Can we calculate internal resistance? FR into L should be equal to QI into R. FR into L, 8 into 0.1. Charge is 1 coulomb. Current given 1 ampere. So what is the value of R? R should be equal to 0.82. Okay, look at all this.
Ampere, sir.
Resistance, no? Internal resistance. Why ampere resistance? Okay, do remember something, the information on cell also can be asked like this. You have to be alert. This is the terminal voltage. This is applied EMF. This is the internal resistance. I'll write down all the things. This is the terminal voltage. Applied EMF. Internal resistance. Okay, let's go for grouping of cells concept.